Alright, welcome back. Today we're going to finish the lecture that we got most of the way through last night. We're going to start tonight talking about sample programs. If you will go into your Robot C, you will see, and some of you may have already noticed, that we have these what's called you can open sample programs. And what will happen when you do that is you're going to get all of these other programs, and one of them they have listed is a PLTW one that's there for us, because PLTW is a big-time user of their materials. But there's also all these other ones on how you can get them to use it. Basic movement, bumper and limit switch, LCD, light sensor, and so forth. So here's all this sample programming in there. I would come to remember that if I was you for later on, because you can sometimes pull up templates that are already going to do some of the stuff you want them to program to do when you get ready to start programming here in about 2 weeks. Natural language. Robot C uses natural language. It's a new language developed specifically for PLTW. Lines of code for common robot behaviors are consolidated into single commands. Forward, line track for time, stop, until bump. Natural language is an additional platform type in Robot C, and most of us did this the other day. Right? We went in there and we changed it, went to Robot platform type, and a lot of us set it on Vex Cortex 2.0, but we want to go innovation first, natural language library, Vex Cortex. Robot motion. Well, these are commands that cause the entire robot to perform a behavior. And what I want you to see is it's underneath natural language. It's underneath natural language. Robot motion you'll have to open up. And then we've got all these different types of movements here for robot motion. Movement. All right. Command that allows you to control individual motors or servos. You're going to use this a lot. You're going to use this a whole lot. And as you can see here, it's underneath natural language, it's underneath movement, and it's set servo. We've did some, you guys have been doing a little bit of hooking up with the servos and learning a little bit about servos. Start motor. The computer's not going to know to start the motor unless you tell it, and it's not going to stop the motor unless you tell it to stop. Special is another language. Special deals with the flashlights and the LEDs. The same thing. Turn them on, turn them off. Computer doesn't know it unless you say it. Until. This is something that you'll use quite a bit. It's a command that allows you to create behaviors where the robot acts a certain way, such as the motor runs or does this until a certain event. And what this is going to typically be is until bump. Now that's hard for students to remember. Until bump, that right there is our bump switch. All right. Until button press. Until dark threshold. That has to do with the light sensor. Encoder counts. If you spin that encoder so many times, it keeps track. Light threshold until the potentiometer gets to a certain position, less than a certain position, and so far, and so forth. So these are all different commands that we have that'll keep a motor doing something until this is done. This is basically, these are all, think of ways of hooking up a switch. Whatever it's doing, it's going to keep doing until the switch is thrown. Well, whether it's a bump switch, an encoder switch, a potentiometer switch, a touch switch. Wait, you'll start using wait already. Wait tells you how long to keep something going. Instead of doing it until something happens, you can just simply say, we want this to run for 0.5 seconds. We want this light to blink on for a second, off for a second, on for a second, off for a second. But that wait is a way to adjust how long something happens without using a switch. This is something I want to point out, is at some point you guys are going to have some type of device where you want a tray or something to be at a specific position. Well, motors are not a good way to move something back and forth. Motors are a good way to move an object forward, backwards, like a car, but it's not going to be very accurate, right? Motors have a very low accuracy, and the reason that is motor speed is affected by battery power. Your battery is going to have several different powers to it as you're using it. If you want, and because of that power, it's what keeps it from being very accurate. If you have two things you want, and you want to, let's say, I don't know, maybe it's just a rod, you want to be here, and then at a certain time you want it to sway over here at a specific spot. Every time you want it here, or every single time you want it there. A motor is not going to be a good use for this, because you tell a motor how long to run, but how fast it's going to run is going to be determined by the battery power. So early on, it might be going exactly where you want it, but as the battery gets weaker, it won't be moving as fast, but it's still going to run for as long, which means it might be here, and now it's not where it's supposed to be. So if you have two different positions, that's where we use a servo, because a servo is not set on distance. A servo is reset to location. Touch sensors. All right. What I want to make sure we discuss right here with these touch sensors is 1 means it's been pressed, 0 means it's been released. Bouncing may occur when sensor is pressed or released. Value may bounce between 0 and 1 very briefly and quickly. Very brief weight can be inserted to reduce bouncing effect. So one thing that's done quite often after you use a switch is you tell it to give it a weight of 0.05. And what that does is that eliminates this a little bit of a bouncing action. It waits 0.5 seconds after it's been pushed before it reacts. Well, hey, that's it for today. I'll catch you on the flip side.